Alright, we're going to start some lathe training today. It's really important that you know that these are dangerous machines, and no hoodie ties, even if they are tucked in. No gloves. Tie long hair back, not below your neck. Stop machines to remove chips and make adjustments. No earbuds, okay? So we have this. Some other kind of safety warnings right here that you should read, as well as turning. Okay. All right, so it's very important that you constantly think safety, though. You know, long hair and hoodie ties could really cause a serious accident. All right, so we have a handout here we're going to be looking at, and you should be trying to memorize the main parts of a lathe. We have 4 different ones. On day 1, you're going to be getting a demonstration from the teacher or a mentor, and then going through some of these just pre-item checklist things. One thing is we want to have sharp bits. I'm going to cover that really close. So the ones we're going to be using most is going to be the right hand cutter, also possibly the left hand cutter, the parting tool, and the chamfer as well. So on this machine right here, there's a power button here, and if you push it this way, it's going to spin like this, and that's what we want to have happen. So I'm going to push it. You might have to do that more than once, but you want to keep the same angles. Don't make this point round. We'll have a different bit for that. Sometimes also, if there's some stuff on top of here, you can use the extra fine part of the file here and just file the top of this slightly, okay? But you want to do it, make sure you have a sharp tip. On a left-hand cutter, you want to have the button go this way. So like that. Like this, and this side. Okay, here we have the parting tool, and here's your work. This is a 1-inch thick aluminum 6061, and we're going to put it inside of our 3-juck chaw like this. You want to go ahead and tighten it, and then you want to turn it and make sure it's spinning good. Okay, that's important. Watch this. That's bad. That's very bad. You're going to have an accident like that. How far to stick out? You can stick out 3 times the diameter, no problem. But if you stick out more than that, if you're sticking out this far, then we have to support this side with a live center, something like this, or a steady rest, which we'll go over later. But always try and have your work be as close in as possible and your cutter close. So we're going to go ahead and use a right hand cutter. So this is called the quick change tool post, and drop this in, and this knob right here raises and lowers this, and that's important. And you want the quick change post to be this surface right here parallel with this here. So don't have this be an angle. On this project, you really should not have to ever loosen this. You shouldn't have to go like this. So just keep this perpendicular. And this cutter right here should be angled a little bit out like this, which you can see it is. It's going to cut perfect. So now we need to level out the tool. So I put in a straight piece of metal here. What you want to look at is this level? And the answer is no, it's not right now. This is not level. So you're going to raise and lower this screw right here until it looks vertical. Okay, so that's good. Once that is set, you want to take this and lock it in. So now you can see that by pulling this, this is locked in. This screw here is tight. The compound rest is tight. This bolt right here is tight, as well as this one right here is tight. My work is tight. You spin it by hand and it's spinning good. Okay, how fast should you spin the machine? So we're going to go 4 times 200, and we're going to divide that by the diameter of the lathe material. Okay, that's the speed you're going to cut at, and that's going to equal your revolutions per minute. Here's 2 examples here. I would say for almost the entire thing, we're going to always be spinning it in the forward direction. So this right here is forward. This is forward. Sometimes, it's pretty rare, we might go in the reverse direction, maybe for doing some threading operations. As far as setting the speed goes, there's lots of numbers here for speed. So here's 800, and so I'm going to move this knob right here. Here's 800. I'm going to move this knob so that it's in line with it. And if it doesn't want to move, you might have to move the chuck a little bit. So it's an 800. You can see it says Y right there. And over here, it says Y. And so this whole column right here is Y. This one's X. And then you can see 800 is a blue number. And down here, we're in blue. And so on this machine right here, if we turn this knob down, it's going forward. Move it up, which you don't want to do, is reverse. So that's forward. Over on these 2 machines right here, you can see we have forward, reverse. You want to unforward. The speed is changed down here while the machine is on, but these are worn out, so it's mainly kind of going by experience and how it sounds and how it looks. On this LeBlanc machine right here, we have forward and reverse. So I'll do forward. And then this is our on-off handle. Or down here, to change the speed, this is the number here. So if I want to go down, just let it do that back and forth for about 2 seconds. So if I want to change speed, that's it. That's how that works. All right, here is your project plan, your engineering drawing. And it's important with your dimensions, you really try and be accurate. Down here it tells you if there's 2 decimal places, you can be within 10 thousandths, 3 decimal places, 5 thousandths, okay? So the first thing we're going to do today is this cap. This is the first thing that we're going to do, this cap right here. And what's important to know is this right here, that it's 3/4 from here to here, and it's 3/4 thick. Okay, so we're gonna, it's 3/4 from there to there, and 3/4 from there to there, or we could say 750 thousandths. So that's what we're gonna make first, and you should go through these safety procedures each day. All right, you should go through these safety procedures each day It's very important for your safety. All right, so we're always going to try and pre-plan what you're going to be doing. Get a plan, do your operations in the best order to get done the quickest, most efficient way possible. This here is a suggested plan, you know, for a beginner. It's not the only way to do it, but it's a good way. So we've got the material, and we're going to face one end with a right-hand cutter. And you'll notice that for each one of these main parts, that down here is the process explaining exactly what to do. So if you read just this here, unless you're experienced on a lathe, you're not going to know what to do. So you want to kind of read step 1 and then go down here to process 1 and go down here. Okay, we did the speed. We're going to face the end of it until it's clean and set the travel dial to 0. Okay, so we're going to do number 2 right now. Okay, so here it is. And I'm going to turn the machine on. So the end's done. So now with the travel dial right here, I'm going to go ahead and set this to 0. So what you want to do is move it until both dials are moving. So the inner dial is moving and the outer dial. First set the inner dial so that the black needle is at 0. And then move the other direction. So now the outer dial, the red needle is with the 0 there. Okay, so that's how that's set. On the outer dial, each mark is 1/1000th of an inch. On the inner dial, it's 1 inch between the 0 and 1. So if you need to go several inches, you could look at the inner dial to move quickly. Okay, so now what I'm going to do is I'm going to go ahead and back this out here. You could carefully take off any, the travel dial is set. So now I'm going to move this knob right here over clockwise. It's 100,000ths, 200,000ths, 300,000ths, 4, 5, 6, 7, 150, we're going to stop. 750. So that's what just happened right there. And now what I'm going to do is I'm not going to move this knob right here. So I'm going to loosen this little set screw here. And without touching this, it's really important I don't touch this right here. But I'm going to go ahead and set this guy at 0. And I'm going to lock in this knob right here. Alright, so that's set at 0. That's important. So now, when I move my work over here, alright, so here's our digital caliper. And I'm going to go ahead and turn it on. Make sure it's in IN for inches. So that's fraction, millimeters, IN, that's what we want. And we're going to go and close it. And then click the 0 button if it's not 0. So that's 0'd. So now we're going to take a measurement. So you can see I have 956 thousandths. Okay, so what I want to do is I want to get to 750 thousandths. All right, so 0.956 minus 0.750 is 206 thousandths. That's how much I need to take off. Okay, so what I can do now is I can go ahead and go in, let's say 50 thousandths, and do a cut. And I could go in another 50. Could go in more, less. Just kind of getting a feel for it. So now we'll stop and take a measurement here. I've gone in 150 thousandths. So I should have about 56 thousandths more to go. Let's go ahead and just see. This is saying because the dials here aren't always perfect. It has to do with how soft your material is, the machine, the force, the speed, a bunch of things. But it's saying right now, so right now I'm at 806 thousandths, so I have to take off 56, so you can see it's pretty good. We want our finishing pass to be taking off just a couple thousandths, so keep that in mind. So I have to take off 56 thousandths, so I'm going to go ahead and take off 50. Just to be safe, I'll do another measurement because I really want to get this guy at 750. It's saying I have 9 thousandths to go here, so I'll do about 6 or so. Alright, so basically you can do this. Had a nice finishing pass there. I just took off a few thousandths. Got 5 more to go. Alright, so I'm really close here. Just have about 2 thousandths to go. Alright, and we got it right there. Okay, I've put in a sharp parting tool, and I made sure again that this piece of metal is vertical. It's really important here. Alright, so we're on page 2. We did all this right here. Now we're on step 4. I'm going to go ahead and mount a parting tool. We're going to do an O-ring groove to 625 thousandths. With the power off, position the left edge of the parting tool near the left edge of the previously turned 750 thousandths diameter. And just contact with the material. Set the crossfeed X dial to 0. It's called crossfeed. Because we're going to plunge cut 1/8 wide, slow the turning speed to 250 RPMs. And basically we're going to power on with cutting fluid, slowly cut until we get to the desired 625 thousandths, which means we'll be taking off 125 thousandths. So as far as getting the machine down to a lower speed, this machine is really pretty easy. Just got to find a number that's around 250. I see it right there. Okay, I'm already in the right position there. You can see it's in the X there, so I have to go over there. So that's X. And you can see that the 250 is a red number. So here, I have to go to red number. On these two machines right here, what you have to do is back here, there's some pins. And what you have to do is you have to pull these pins, pull them out. So the pins are out. And now it says pull out for low gear. So pull this out. And now being low. Alright, so I've got this parting tool up against my metal with the power off. And I'm going to find my set screw here and set this guy at 0. So that's set at 0. And at this point I could go back a revolution. And if you have some kind of a little bit of an angle right here, you're going to go ahead and try and get rid of that angle. So again, the tool is in tight. The tool is in tight. Could use a little bit of cutting fluid right here. And we're going to go in 125 thousandths. And back at 0. So I'm going to go in here. If you want, we could just go ahead and take a quick measurement. We're going to get the right desired diameter. All right, so we've gone in just about 125 thousandths, measured it, and it's right there. So that's what you want to do. Get that at 625 thousandths for the O-ring groove. All right, so now what we're going to do is install the chamfer tool in the tool post and apply the chamfer to the diameter end. And then we're going to apply the thread with the lathe or threading die. So just look at the plan here. We know that we have a 1/8 inch parting tool, which is 0.125. It says here, O-ring groove 1/8 parting tool, diameter 625 thousandths. So that's what we did. And we're going to apply a chamfer on this end right here and then cut the threads. All right, I have the chamfer tool installed. It's locked in, it's level, and basically it's right here. And we're just going to go in. Also use the cross feed here too. Alright, so a chamfer basically takes the sharp edge off the metal. In this case, we're going to be putting in a die on here. It's going to help it to get started more easily than if you didn't have a chamfer. Now here in the plan it says 3/4-16. What that means, you want to have the diameter of threads be 3/4, and then there's 16 threads in 1 inch. Okay, 3/4-16. Then if you look at this die right here, it says 3/4 right there. National fine, and then 16. So this is definitely the right one. Look at it too. You can tell that it's gonna, in this area right here, it's gonna first get the threads started, and then towards the second half, it really cuts real threads. So we're gonna have our end touch this side. Okay, so what I've done here is I have the die set up here. This is called the tailstock. I had to basically loosen this, move the tailstock over with my hand. You want to have this loose. On this tailstock, this is what tightens and loosens it. So you'd want to move it over, tighten this, make sure this is just a tad bit loose so that this works right here. And then on this tailstock, there's a button down here. So this locks it in, unlocks it, and then this should be a tad bit loose. All right, we're going to cut the threads now. It's going to be a little hard to do this one-handed, but before we start, it'd be a good idea to get some cutting fluid and just kind of get some cutting fluid on that. And what we want to do this whole time is maintain a little bit of pressure with this going this way. So this is going to keep it, we want this to be a little bit of tension there. And then we're going to have an adjustable wrench going here. And we're going to basically cut the threads. So cut threads a little bit like that. And then a little bit of tension. Cut threads, and then a little bit of tension. Now, after it gets started, it's going to take more force. So I'm going to cut the threads, and then you want to move it back up here to kind of release the threads into the flutes of the die, and get back where you started, and then apply a little bit of pressure right here, and keep doing that. All right, I could just feel myself going past the O-ring groove, and now really I can't go anymore. It's stopped against that edge. And so now I'm going to back it out. So what we're going to do is go like this, pull this back, take the wrench off, and then you might be able to use your hand, but basically we're going to just move the chuck this way and reverse with no power and get it off. All right, so you can see it's coming off here. Just like that, no power. All right, here's what it looks like. To clean it up a little bit, but basically I got my threads done. On your next lathe project, or Metals 2, we will basically cut the threads with a thread cutter, and that's why all these numbers and stuff are here, because if you want to do a 3/4 16 thread, you can set these dials so the machine will do that for you. But that's for a different lesson. All right, so we just completed step number 6. If we're going to 7, let's just see where we're at. This is kind of talking about knurling. So you can see that we've basically faced it, we turned it down, we did the chamfer, we just did step number 6. So now we're on step number 7. We're going to reposition the shaft and do our knurling. So here we are, step 7. So basically loosen the chuck and move the material outboard, leaving about 1.5 to 1 inch diameter of material outboard the chuck. But let's just pause for a second here. We're actually going to want to do a 1/2 inch of knurl here and a 1/2 inch here. So that's 1 inch of knurl. We're going to have to part them. That's 1/8 of an inch. So we're actually going to knurl 1.25 inches of knurl. That's what we're going to do, so we can get both done in one operation. Alright, so going to have about 1.5 inches out. Like it says, we're going to knurl about 1 1/4, make a little line, and mark a line 1.25 in from the right side of the stock where the knurl is to stop. Mount the knurling tool, move it near the chuck to verify there's sufficient clearance between the chuck and the knurl tool, and apply the needed length of knurl. Readjust as necessary, tighten the chuck. So we're going to go through this step here. We're going to go about 100 RPMs and use cutting fluid. Alright, got my knurling tool in. Set this at about 1.25, and just go ahead and you can just scribe a line like that, so you can see my line right there where I'm going to go to. And as far as the knurling tools go, you don't want to have this hit the chuck. That would be really bad. So basically, I'm at the knurling tool, the left edge into the line, and I got a little space between the chuck. You definitely want that safety space. Don't have it be where you're going to be any closer than that. And right now, if you want to know how far mine is sticking out here, it's approximately 1.76. So you could say have it stick out 1 3/4. That way you have a little bit of space right here, because you don't want to be too close right there. Alright, now with the knurling tool, what you want to do is the tool should be loose right now. So it's loose, and we're going to drive it in, and so we're going to drive it in, and it's going to find the center. See that? It found the center. And then you can verify that both wheels are moving. So you can see the top wheel is moving, and then the bottom wheel is also moving. It's a little hard to see. You can see the top wheel and the bottom wheel are moving. So we're going to get... okay, I have the knurling tool in. The knurling tool is about halfway over this edge here, about halfway. And I went clockwise until it was touching. I verified that both wheels are moving. So I verified that, and I got this thing set at 0. We're going to be using some cutting fluid. So, and we're going about 100 RPMs. So I'm going to go in about 30 thousandths here. Take a look. And then I want to hold this knob and then hold this in place with my right hand, my left hand, move this knob over. Alright, so I have my knurl there. If it has the cross hatch, you know that both wheels are working. If you only see the lines going just this direction, then you have to do it over again because both wheels weren't moving. And I could go deeper there. You know, you can go, I would say go 30 thousandths to 60, somewhere in there. So with the knurling, be sure that you and your partner really read this. It's really important. And then it goes on to the next page right here. So we did all this right here. So now we're on to step number 9. And step number 9 is going to be chamfer the knurled ends of the cap, 45 degrees 1/16 deep, and then we're going to cut off the cap. So we're going to do steps 9 and 10 now. Okay, we have a sharp chamfer tool installed. It's level, it's locked in, it's right just touching the metal, and this is set to 0. The travel dial is set to 0, and we're going to go in 1/16 of an inch or 62 thousandths. Okay, so after that, I'm going to go ahead and here I'm at 0. I'm going to also back it out a full revolution. So we're a full revolution away. And now we're going to go over 1/2 of an inch. 1/2 an inch is 500 thousandths. So we're going to go, that's 100 thousandths, 200 thousandths, 3, 4, and 5, right there. So now I'm going to go in a full revolution to get back where I started from, and then we're going to go in 62 thousandths. Okay, so we're on step 10. Got 250 RPMs. We're not going to use anything supporting the right side of the metal. Alright, it's time to have our cap fall to the ground. We're going to do that by using a parting tool here. And it's sharp, it's level, it's locked in, and the right edge of the parting tool is basically at the bottom of the chamfer, the bottom of the V. We're about 250 RPMs, and we're going to use some cutting fluid. We're going to basically have the tool fall to the ground. I'm just going to pause here and make sure I still have my chamfer here. If for some reason you made a mistake and you got rid of your chamfer, you could change out the parting tool right now, put the chamfer in, and get that chamfer back on the left part of your cap. But it's going well for me, so I'm just going to proceed. Perfect. You can see it fell down there, and that's exactly what we want to have happen. Had we been supporting the right side, it could have flown up and been dangerous. So, let's get our cap. Here it is. Might be a little hot. So here's my cap. It's done. And it has a little tiny knob there. That's not a problem. We'll fix that later. But that's done. So now we're on step 12 here, and we're going to be basically having it stick out at least 3¼ inches, maybe up to 3½. You can see I have a mark here at 3¼ I went a little bit beyond that, but not too much more. And basically what we're going to do is we're going to use a center drill. We're going to go in about 5/16, and that'll get the hole started with a center drill. Then we're going to drill with an 11/16. You can choose to do a pilot hole as well, and we're going to go to a depth of 2 3/4. So looking at our plan right here, it says drill 11/16, 2 3/4 deep, then tap it with a 3/4-16 tap. As far as a center drill goes, this is a center drill. It's used to start a hole, find the center. It's a very stiff, robust type of drill called a center drill. I'm going to start with that. Then with a pilot hole, it's important, if you do one, that you select a good sized drill. If you selected this number 11 drill, it'd be a mistake, because you can see the drill stops drilling there about 2 1/4. So once you got to 2 1/2, the chips could not escape and the drill bit would snap inside your part. So that'd be a bad choice. This larger 5/16 drill, you can see that it can drill, a little over 3 inches, no problem. So going 2 3/4 would be fine for this guy. With our 11/16 drills, this one is a tapered shank, meaning that it's thicker here and thinner here. Plus, it always has this end here, so that the drill cannot slide out in the chuck. So it's a tapered shank drill, and you're going to need an adapter for our lathes. You're going to need this adapter for 3 of our lathes, and then if you're on the LeBlond, you'll need this one, the bigger one. And so the way these work is you just put this in, and you rotate it until that locks in there like that. If you have to get the sleeve off, and you can't do it with your bare hands, this is called a drift, and the drift is meant to go inside of here to push it out. So that's one option. We have one of these drills. The other option is using a straight shank drill. And so if I grab the 11/16 drill, you can tell that this is not tapered, it's a straight shank drill. If you're using a straight shank drill, you want to install the Jacob's chuck, which has on the back end of it a tapered shank, which will be up here. And then you want to install your straight shank drill into the Jacob's chuck, tighten it, and then go ahead and tighten it with the chuck key. That's how you would get that in. So we're going to go ahead and start with the center drill. Right, I'm up at about 1,000 RPMs. That's about what an 11/16 drill would run at. So everything's ready. Remember that for this to work, when you're going like this tailstock has to be locked in, and this also has to be just barely loose. That way this thing will work. Okay, so now I got a 5/16 drill in for a pilot hole. We want to go in 2 3/4 deep exactly. So how do you do that? Well, here in the tailstock, there's a ruler right here, and so we want to have this be out 1 inch or more to be stable. Otherwise, if it's not out a full inch, what can happen is that this thing is kind of jiggly and not set. So I'm going to have this be out exactly 1 inch, so right there. And then our work, okay, so you can see, I'm trying to get the camera here so you can see it. All right, so we're out 1 inch. And then we're going to move this thing to where the tip of the drill is right there. Then we're going to go ahead and lock this in. And then I'm going to crank until I get to 3 3/4 because it's out 1. So I want to get to 2 3/4 deep. It's already out 1. So I'm going to go ahead and start drilling. Occasionally make sure that everything is clear. Alright, so I could put the final drill in like this, or I could take this out and I could put in a tapered shank like this and make sure it's out 1 inch exactly. Move it on over. Lock this in. Now keep in mind, this is going to be pretty hot. So if you take this out, just know it's going to be hot. Step 13 says, chamfer the inner edge to 3/4 of an inch with boring tool using compound set at 45. So what that means is that this is the compound. So I've loosened a nut here, and then either on this side or this side, depends on the lathe, there's going to be some markings so you get the degrees right. So you can see right there, it's set at 45 degrees. So I have these tight. That's important. And then I have the boring tool in, and you can see I have the height adjusted correctly. Alright, so the boring tool is used to take off metal on the inside, and so it's set up right there. And so right now I got the tool locked in, centered, everything's tight. I'm going to go and turn it on. And this is, I'll move this one right now. Then take a measurement. If you want to take more off, what you're going to do is you're going to go to a few thousandths this direction and then back in here like that. If you want to take more off, you can go ahead and turn this out and go in more here. Alright, so now we're on step 14 here. So we're going to tap with a 3/4 16, about an inch deep. We're going to use a tap guide right now, put it in neutral, apply oil, use an adjustable wrench. Okay, so a couple things to know about. Getting back to our plan says it right here, tap 3/4 16, and you can see it in the top view, the section view here, where the threads are. We just did our little chamfer on the inside there. A couple things to note is that with our particular tap here, it doesn't start cutting real threads until right about here. So if that's why we're going to go in a little deeper. So this section right here is about 0.3, so 0.75 plus 0.3, so we're going to go just over an inch, and that way we'll have 3/4 of an inch of real threads. Alright, this is called a tap guide. There's 3 of them in the wooden cabinet, and there's a spring on this, and as opposed to just throwing this in a vise and doing a tap, it's much better to do it on the lathe because you can keep everything lined up. So what we're going to do is we're going to have this here and the tap guide right behind it. Alright, so I'm going to go ahead and engage the spring a little bit. So I'm going to go like this and make sure that spring is engaged. Again, this is, the tailstock is locked in, and we could just use a little bit of cutting fluid. We're not going to use any power at all, and basically we're going to go ahead and just spin it like this by hand. Spin it by hand. So now it's getting kind of hard. It's going to start cutting real threads. And so then, just like with the die, we're going to go ahead and I got that blue piece of tape there so you can kind of see where an inch is. All right, got tapped in there just over an inch. I'm gonna go ahead and move my tailstock away, and then I'm gonna go ahead and just turn this counterclockwise, and don't let the tap fall to the ground. It should come right out here. All right, tap will come out. Do not drop this. All right, here's our compressed air, our little hooky on-off button here. So that's on. Don't ever aim this at anybody. You'll be out of the shop for a long time. So, if you could go ahead and put it in here. And also here. Alright, I had to put the tap in a second time with a little lubrication, blew it out, and then I got it to close. So the next step is we're going to clear up this little flaw right here with a right-hand cutter. So it works tight, this is tight, this is tight. Now, if for some reason you cannot unscrew this and it's hard, come get me for assistance. There's a trick to getting this off. You don't want to put a wrench on here and ruin your knurling. Okay, it's important. So now I'm going to go ahead and take this off. Save this for later. And you'll see that you know, we verified the threads, we applied the cap, you know, and then we removed it. And now we're going to basically cosmetically turn the body. Set the spindle speed to 800, set the carriage feed to 5 thousandths per revolution, install round nose chamfer tool on the tool holder, and basically we're going to do auto feed. If you don't want to do this part, you can do it manually, but it's very good to learn how to use the auto feed. But you really have to have your game on, because what's going to happen is that this is going to be automatically moving towards the chuck, and it could crash in here. Alright, we have a round nose chamfer tool here. Alright, don't forget RPM 800, spindle speed 5 thousandths. So on this machine, that right there is just over 5 thousandths. It says AEH, and it has that icon there. So what that means is right here, I put this at A, I put this at E, put this at H, and I put this thing with that threading looking icon. So that's how we get 5 thousandths. But essentially what you want to do is have the machine move slow. Now we're going to be applying, again, this is sticking out about 3.5 inches because our body's 3 inches and we don't want to run into the chuck. We're applying pressure against this, and so in this case it'd be very wise to put in a live center. This part rotates, and so basically I'm going to lock this in, and I'm going to engage this, and once it's engaged I'm going to lock this in, and so when I turn it by hand you should be looking for this moving. So now I've supported this right side, so if I apply pressure way on the outside here it's safer. Could you do it without it? You could, but you know, the longer your stick out, the more critical it is. It depends on the thickness of your metal and what type of metal, but you know, when you're out 3 times the thickness of your material, you should be thinking about supporting it to be safe. So I got my tool in here. It's round nose chamfer tool, and you might be able to see it, but I did mark it at a 1/2 inch here. And so basically, I'm going to get this thing lined up at a 1/2 inch. But before I do that, you want to practice with the auto feed. And you definitely don't want to have this thing be close because it could take off right towards the chuck. So I would say move the carriage away from the chuck. You don't want this to touch that. That's the danger. On this particular machine, this knob here does one direction, neutral, the opposite direction. So that controls which way. And then when I turn it on, this is spinning. And if it wasn't spinning, like if it's just off, so these basically do auto feeds. And then there's some knobs over here. Every lathe is a little bit different. But on this one, if I pull this up, that starts moving. See it? If you want to go the opposite direction, rotate this. Also, I can move this knob in, and that moves that knob. Okay? And so, just get a feel for starting and stopping it. It's really important. Alright, so I have my mark a little more clear now. You can see it. It's lined up. 1/2 inch. And I'm going to go ahead and stop it when I get close to the chuck. Really have your game on. You know, you have a text message, your phone vibrates, just ignore it. You really have to focus here. Alright, so I'm going to turn it on. Okay, I just started to touch the metal, so I'm going to go ahead and set my 0 here. And we want it to be a diameter of 975 thousandths. We started off with 1 inch, so we have 25 thousandths to cut. So I think we should cut 20 and then take a measurement and then do a finishing pass. So here we go. So that's pretty tight. If you want to make things a little bit easier on yourself, not so critical here, you could have your work be farther out, because as long as you're supporting the right side, you can definitely have it more out. You can see the finish is really nice here. I mean, I don't see any need to put sandpaper on this or emery cloth, but it's because we had the right tool for the job, we had the right feed rate, the right RPMs, and got a nice finish. So now we just have to check out the measurement and get to our final measurement. So here's our reading, 995 thousandths. So we have to take off 20 more thousandths. So I'm going to go ahead and take off another 20. What we want to do now is we want to get this live center out of the way. We're going to take out our tool. We're going to put in our parting tool. This one back. And we're going to take a measurement now. So go over here. Okay, before we think about parting this, we really want to use our depth gauge of this device, because if we part it at 3 inches like the plans say, what if we drilled in too far? We'd have an issue. We'd have a hole on the left end. So basically, we want to use our depth gauge here. So you're going to put this in, and you know, I got 2.75, but what you want to do is have this corner right here, touch this edge right here, and then you'll know. Just make sure that you're not at 3. Like, you should be definitely less than, say, 285 thousandths. If you are more than that, come see me. We'll make an adjustment. So that's first. Next thing here is we're going to go over here and, okay, I have my parting tool set up like that. My travel dial is set at 0, and I'm going to go over 3 inches. I said earlier the inner dial is for inches, so we can easily go over quickly without counting every revolution until that black needle is at 3. And then we know where to go back a little bit. Alright, so we're at 3 inches here. Are we parting close to the chuck? Yes. Do we want this here when we part? Definitely not. We want this to fall to the ground. It's very important. So we're parting close to the chuck. We've got to lower the RPMs down. So let's go down to about 200 or so. So I have to move this. There we go. It's at 200. It's on the X. 200's on the X, and it's a blue number, so we're at 200, and we can use a little bit of cutting fluid. This is tight. That's tight. We're square. Okay. We could stop here and put our chamfers in, or we could do it later. If you did it now, we could go ahead, let's just do it really fast. And we have to have one 1/2 inch over to the right or at 2.5. So go ahead and set this to 0. And I'll go out 1 full revolution and go over 5. 1, 2, 3, 4. That's right there. And we're nice and slow here since we're on the edge. Back right where we started, we left off right there. And part it all the way through, no live center. Could be hot. Alright, it's a little warm here, so now we're going to fix up that other edge there. If you have to put your nice container back in here for some reason, be sure to really clean the inside of the jaws very well, and wrap your piece of work with a piece of paper, or just not a whole piece of paper, but some paper. Could have done that auto feed if you wanted to, but clean up that mark right there. Alright, go ahead and grab an O-ring there and screw it on. Get your grading card, and then we'll be basically measuring this and making sure it meets the tolerances. And thanks for watching. Let me know if you have questions.